June 2017, an 8-author paper hits arXiv. Title: Attention is all you need. Cheeky title, confident. It proposes a model with no recurrence, no LSTM cells, no gates, just attention, and it beats every previous machine translation record. Within 6 months, half the field pivots. Within 3 years, that architecture is the shape of GPT, BERT, T5 Chinchilla, Claude, and everything else. This is the paper. Last video, LSTMs, the state of the art for 18 months. Google Translate's production model. This video, the paper that walked in and made all of that obsolete. Today we tell the story, what the paper claimed, why it was right, and why the field flipped so fast. Next video, we open the hood and show you the mechanics. V4 left us with LSTMs on top. Google Translate running production LSTM in 2016. Sequence to sequence, encoder-decoder, gate-controlled memory, the whole field had converged on this shape. Recurrence was the model of language, everyone said. The clock ticks left to right. The model reads one word at a time. The hidden state remembers. Obviously, that's how it has to work. Today's puzzle. If recurrence was so obvious, why did throwing it away work better? The paper's thesis was radical. You don't need to read a sentence left to right. You just need every word to be able to look at every other word directly, all at once, in parallel. That's it. That's the whole idea. And once you say it out loud, it's obviously simpler than the LSTM. But it took an 8-author team to prove it. Today's 3 beats. First, the setting. What was attention before 2017? Because attention wasn't new. Bahdanau, Cho, and Bengio had introduced it in 2014. The 2017 paper's move was radical for a different reason. Second, the paper. What it actually claimed. Why the title was a real claim, not just marketing. What GPU friendliness had to do with it. Third, the aftershock. What happened in the 6, 12, and 36 months after this paper landed. And why every LLM you touch today is a descendant. Beat 1. Attention before 2017. Bahdanau, Cho, and Bengio, 2014. Neural machine translation with an attention mechanism. Their setup. An encoder LSTM reads the source sentence and produces one hidden state per source word. A decoder LSTM generates the target sentence. At each decoding step, instead of only using the final encoder state, the decoder attends to all encoder states, computes a weighted sum, deciding which source words matter for the current target word. That result was huge. It fixed a specific problem. Cramming a whole source sentence into one fixed-size vector was bottlenecking translation quality. With attention, the decoder could reach back to any source word. Long sentences got dramatically better. But, and this is the key point, attention was bolted onto an LSTM. The LSTM was still doing the sequential work of encoding and decoding. Attention was an accessory, not the main event. The 2017 paper's move was to invert that, delete the LSTM, keep only the attention, and to make that work, they had to answer 2 objections. First, how does the model know word order without recurrence? Answer, add a positional encoding to each input embedding. A little vector that says, I am position 7. Second, how do you fuse the attention outputs into a real representation? Answer, stack multiple attention layers with feed-forward blocks in between. Attention, mix, attention, mix. Beat 2. The paper's core claim. Attention alone can replace recurrence. The full architecture, call it the transformer, has an encoder stack of 6 identical layers. Each layer has a self-attention sublayer and a feed-forward sublayer. The decoder mirrors it. That's the shape. 6 encoder blocks, 6 decoder blocks, attention and feed-forward, over and over, no recurrence anywhere. The specific result. On the WMT English to German translation benchmark, 28.4 BLU, state of the art. On WMT English to French, 41.8 BLU, also state of the art. Trained in 3.5 days on 8 GPUs. The previous state of the art was a Google LSTM system that had taken weeks to train on more GPUs. This one was better and faster, which was the second, quieter shock. Why faster? Because attention is parallelizable and recurrence isn't. An LSTM has to compute step 1 before step 2. The whole point of recurrence is that step 2 depends on step 1. Attention has no such constraint. Every word attending to every other word can happen in parallel, which on a GPU means every attention layer runs at the speed of one matrix multiply, not one word at a time, all words at once. Beat 3. The aftershock. 6 months after the paper, early 2018, every major NLP lab has pivoted. Google publishes BERT, which is basically the transformer encoder stack with a masked language modeling objective. OpenAI publishes GPT, which is basically the transformer decoder stack with a next word objective. Same architecture, 2 different training regimes, both work spectacularly. We'll cover BERT versus GPT in detail in video 7. 12 months. Transformer variants dominate machine translation, question answering, sentiment analysis, coreference resolution, every standard NLP benchmark. 36 months. GPT-3, 175 billion parameters. Same transformer decoder shape, just scaled up dramatically. 5 years. ChatGPT, the same architecture, just bigger, better trained, and with a good chat interface on top. All transformer, all from that one paper. One thing to notice, the 2017 paper doesn't feel that different from what came before. Attention had been around for 3 years. Encoder-decoder stacks had been around for 4 years. The paper's move was subtractive. Take out the LSTM and see if attention alone is enough. Turns out it was. Sometimes the most important papers aren't the ones that add a wild new idea. They're the ones that let you delete something you thought was essential. 3 takeaways before the quiz. 1. Vaswani and 7 co-authors published Attention is All You Need in June 2017. arXiv 1706.03762. The paper proposed replacing recurrence entirely with self-attention plus positional encoding, stacked with feed-forward layers. 2. It beat the previous state-of-the-art on WMT translation and trained in 3.5 days on 8 GPUs, both better and faster. Parallelization was the second, quieter shock. 3. Every LLM you touch today is a descendant. BERT, GPT, T5 Chinchilla, Claude, Gemini, Llama. Same shape, just scaled. The 2017 paper's move was subtractive. Delete the LSTM. Quiz 1. Attention was actually invented before attention is all you need. Who introduced it and where did it live? A Hawkwriter and Schmidhuber, 1997, inside the LSTM cell. B. Bahdanau Cho and Bengio, 2014, bolted onto an encoder-decoder, LSTM, for machine translation. C. Vaswani et al., 2017, it's genuinely new in that paper. Or D. Rumelhart-Hinton and Williams, 1986, alongside backpropagation. B. Bahdanau, Cho, and Bengio, 2014, introduced attention as an accessory to the RNN. The decoder attended to encoder states with a learned weighted sum. The 2017 paper's move was to invert that, delete the LSTM, keep only the attention. Quiz 2. Besides higher translation quality, why was the transformer such a practical win over LSTM-BECD systems? A. It had way more parameters. B. Attention is parallelizable, and recurrence isn't, so an entire attention layer runs as one big matrix multiply across all positions instead of one step per word. GPUs. Love it. C. It didn't use ReLU. Or D. It ran on CPUs, faster than LSTMs did on GPUs. B. The paper trained in 3.5 days on 8 GPUs and matched or beat previous systems that took weeks on many more GPUs. Parallelization was the second, quieter shock. Recurrence forces sequential computation. Attention doesn't. Quiz 3. Since the transformer has no recurrence, how does it know word order? A. It doesn't. Word order is thrown away. B. A positional encoding is added to each input embedding, a vector that encodes IM position n so the model can distinguish position 1 from position 5. C. The encoder always reads left to right anyway. Or D. Multi-head attention automatically handles order. B. Positional encoding is one of the two specific fixes the 2017 paper had to introduce to make the no recurrence idea work. Without it, the transformer would treat a sentence as a bag of words. Video 6 goes deeper on how the encoding actually looks. Back to the puzzle. Lecture 6 is the story of how deep learning 8 NLP Vone through V4 walked the road up to LSTMs. V5 is where the road ends and the new road starts. One paper, one subtraction. Next video, we open the hood. Queries, keys, values, positional encodings in more detail. The mechanics of self-attention with zero math required. Next time, how transformers actually work. No math, just the lookup metaphor. Queries, keys, values, positional encoding. The attention feed forward loop, the single picture that makes it click. Hit subscribe.